What's up, everybody? Welcome back to Intuition. So let me start this video off by saying RIP Black Panther. I don't know what's going on, but this year has just been crazy for some reason. So many shocking things have occurred this year. And also we've had this pandemic going on. This year has just been crazy, but somehow we got to find a way to stay strong and keep things going. So in today's video, I want to continue our problem solving series. Specifically today, we're going to cover a couple trick questions that are bound to come up on the exam. All right, stay tuned. Okay, so in today's video, we're going to be covering trick questions. And what exactly is the trick question? Because that's a very subjective term, right? Well, when it comes to trick questions, I think that there are two categories of trick questions. One type of trick question is where critical information is omitted from the question. You'll read a question and you'll try to solve it, but then you realize, wait a minute, there's a missing piece of information that I need to be able to solve this problem. And that missing piece of information will not be explicitly stated. It might be implied, but it won't be stated explicitly. So that's one type of trick question. Then you have the other type of trick question, which is where a question gives you excessive information to send you on a goose chase. So you get a lot of information that you don't need to send you in different directions that lead you to the wrong answer. So that's the second type of trick question that is bound to be utilized on the exam. If we want to prepare ourselves for these types of trick questions, the best thing to do is to practice a lot of problems and to come into contact with a lot of these tricky types of questions to learn how to answer them. And once you've answered enough of them, you'll be able to see these tricks immediately. So in today's video, we're going to cover one of each of these trick questions. All right, so let's look at question number one. Question number one states, a vial of drug R is to be reconstituted with sterile water to a concentration of 1% weight per volume. The vial contains 5 grams of drug R and develops a concentration of 3% weight per volume if 100 milliliters of sterile water is added. How many milliliters of sterile water should be added to the vial to make the 1% solution? So this question seems nice and innocent, right? But it's pretty tricky. So in this question, the pharmacist is going to be reconstituting a certain drug called drug R. So we have 5 grams of drug R in a vial, and we're being asked to find out how many milliliters of sterile water we would need to add to this vial to get a concentration of 1%. So it's a pretty straightforward problem, but there are two ways to get this question wrong. And the biggest way to get this question wrong is to ignore the statement that adding 100 milliliters of sterile water to the 5 grams of drug R leads to a 3% solution. Because you should notice that that doesn't make sense. Because if you have 5 grams and you divide that by 100 milliliters, that's 5 over 100. That should be a 5% solution. So why is it a 3% solution? So there's an underlying piece of information in this question that is not explicitly stated. We know that adding 100 milliliters to this 5 grams of drug R led to 3% instead of 5%, which means that the volume is not just the volume of the sterile water. The volume is the volume of the sterile water plus the powder volume. It's implicitly stated, and you have to recognize that. That is what makes this question a trick question. So let's answer this question taking into account not only the sterile water volume, but also the powder volume. So we know that when we added 100 milliliters of sterile water to the 5 gram of drug R gave us a 3% solution. So what does that mean? That means that 5 grams divided by 100 milliliter plus the powder volume is equal to 3 grams divided by 100 milliliters. So now we can use this equation to solve for our powder volume. But an easy way to do it is to multiply the right side by 5 over 3 divided by 5 over 3. Because 5 over 3 over 5 over 3 is just equal to 1, so you're not changing anything. But what this does is it allows you to have the same numerator on the left side and the right side. Because when we multiply the numerator by 5 over 3, we get 5 over 3 times 3 equals 5. So on the right side, we'll have 5 grams in the numerator. And in the denominator, we have 100 milliliters times 5 over 3, which equals 500 over 3, which is 166.7 approximately, right? So 166.7 milliliters in the denominator. So now the left-hand side has a numerator of 5 grams and the right-hand side has a numerator of 5 grams. So those are equal. So now we just need to make sure that the denominators are equal. So we're going to set 100 plus powder volume equal to 166.7. And then now we can solve for the powder volume. We subtract 100 from both sides, and then we get 166.7 minus 100, which equals 66.7. So that is the powder volume. The powder volume, or the drug volume, is 66.7 milliliters. That is what we need to take into account to be able to get this answer correct. All right, so now that we know what the powder volume is, now we can figure out the amount of sterile water we would need to add to this 5 grams of drug R to be able to get 1% solution. To do that, we'll have 5 grams divided by X. X will be the volume of sterile water we need to add, plus the powder volume, which is 66.7, equal to 1 gram divided by 100 milliliters. And now we do the same thing. We want to get the numerators on the left side and the right side to be the same. So we multiply the right side by 5 over 5. So 5 times 1 gram will be 5 grams. That's the numerator. And now we have the same numerator. And in the denominator, we'll have 100 milliliters times 5, which is 500 milliliters. So now we're good to go. Now we just need to set X plus 66.7 equal to 500. And now we just solve for X by subtracting 66.7 from both sides. We get X equals 433.3 milliliters, which is approximately 433 milliliters. And that will be the correct answer to this question. Answer choice B, 433 milliliters. All right, so let's go on to our second type of question, question number 2. Question number 2 states, a hospital pharmacy has single dose vials of 150 milligrams and 300 milligrams of a drug P. A physician sends in a patient order with the following directions. Give 200 milligrams of drug P IV daily for 7 days. Drug P is prepared by reconstituting the 150 milligrams and 300 milligram vials with 100 milliliters and 200 milliliters of sterile water for injection, respectively. The pharmacist wants to make sure that enough drug P is in stock to treat the patient for all 7 days. Which of the following answer choices demonstrate adequate drug P to treat the patient for all 7 days? This is our second type of trick question where we're given so much information to a simple problem that it's designed to send us on a goose chase. I call these types of problems confusion by excess information. So let's go ahead and take a closer look at this problem to figure out how to deal with it. And basically, we're trying to make sure that we have enough drug to be able to fill a patient's prescription for the total duration of time that the patient will be on the medication. The total amount of time that this patient is going to be on the medication is 7 days. And every day, the patient is going to get 200 milligrams of this medication. So for the entire 7 days, the patient will get a total of 1,400 milligrams for the entire week. And this is where the confusion occurs. Because what you'll do now is you will shuffle through all the answer choices and try to figure out which one gives us 1,400 milligrams of drug P, which would be the wrong thing to do because there's a trick involved in this question. And the key to realizing the trick to this question is to notice the key word that is used in this question. And the key word is the word single. In the first statement of this question, it says single dose vials, which means that each one of these vials can only be used once. For example, if you use a 300 milligram dose vial, you can't take out 200 and say, okay, I took out the 200 and then I'm going to save the 100 milligrams for later. You can't do that. Once you take out 200 out of the 300 milligram vial, you have to get rid of the 100. So now that we know that, this question becomes very easy, right? That if the pharmacy only has the 150 milligram vial, 150 milligram vials will not be enough. So to treat this patient for a day with 150 milligram vials, we'll need 2 vials. 2 150 milligram vials every day for 7 days, then we'll need 14 of those vials. Or maybe the pharmacy only has 300 milligram vials in stock. So if the pharmacy only uses 300 milligram vials, then they will need 7 300 milligram vials. So 1 vial each day. Okay, so let's go ahead and look at the answer choices to see which one will be correct. A says 7 vials of the 150 milligram vials. All right, we just said that would be incorrect because we would need 14 of those, right? And C says 14 of the 150 milligram vials, and that would be the correct answer. But C, 14 of the 150 milligram vials. Okay? All right, so those are 2 types of trick questions. I hope that they were helpful for you guys. For those of you who are still studying, keep watching, keep learning. Every day you can learn something new. So with that said, I want you guys to keep watching, keep learning. And if you haven't already, go ahead and subscribe to the channel. Leave a comment if you have any questions. And as always, I'll see you guys next week. Bye-bye.